didn't fail you this time.
All right, so notes. What's today? Friday the 18th. So we're going to, again, start up above the notes, and let's start with just saying F is some quantity. So F could stand for anything. How much rain we've got, how tall the grass is, like it could, anything. F prime is derivative, but what's another word for derivative? Pardon? Not area. Integral is area. IROC, so that is the instant rate of change. Of whatever our quantity was. So, how much total rain has fallen? How much has the grass, or what's the rate the rain is coming down? How fast is the grass growing? It's the rate of change.
Yeah.
Okay, let's put that with this, the antiderivative. Remember that was on the last test. The antiderivative of the derivative of f is what? The antiderivative of f prime
is
f. Now, on the test, we just had a plus c, but we've since added this a to b stuff. So it's f at the top value minus f at the bottom value. So now if we sort of put these two ideas together, if we integrate a rate, we get a change in the amount, or change in the quantity. That becomes a big, big deal for word problems. They're going to give you a rate and ask you for the change in amount. So you'll have to integrate the rate to get the change in the amount. That's where the notes sort of pick up here. The antiderivative of f prime is f of b minus a. And then what we just said, the integral of the rate gives you the change in the amount. So here's how we use this. If you know the expression for the rate of change of a function, remember that would be f prime, and a value of the function, f of a or b, you can get any other value of the function you like. Because if you know two of the three things in that equation, you can find the third. So if you know f prime and you know one other value, you can find the other one. All right, let's see if we can use this. So example 1, f prime is 5x to the fourth plus 10x. F of 1 equals 3. Find f of 2. And what we're using over and over and over again today is that formula. So I need to integrate f prime to get f. So I know I'm going to integrate 5x to the fourth plus 10x. What do you think my limits of integration should be?
1 to 3.
I like the 1.
To 3.
But I want my limits. My limits have to be x values. So let's go 1 to 2.
I was thinking 3 so you could get 2 in the middle. Then that would probably create more work.
So you got to use the x values either that you're given or that you're concerned about. So we'll use 1 and 2 for this one. So the integral of f prime is going to be f of 2 minus f of 1. Now let's see what we know, what we're looking for. F of 1 we have, f of 2 we're looking for, and this integral we can do. So I'm going to be able to find f of 2. In fact, I'm going to solve for f of 2 first. F of 1 plus the integral from 1 to 2, 5x to the 4th plus 10x dx. So f of 1, that's easy. They gave us that. Now for the antiderivative stuff. Let's pick on some people, right? Yeah, that's 2. Oh, I'm selecting. I saw the name and I wanted to grab it, so it's completely targeted. So Preston, what's the antiderivative of 5x to the 4th?
Antiderivative. Oh, you're thinking on the screen. I can't think right now. The rules. The antiderivative.
The antiderivative.
Okay, fine. 5x5 over 5.
Yes.
Not incorrect, yes.
I'm going to go ahead and reduce that to x to the 5th. But what you said was right. 5x to the 5 over 5. Increase the power by 1, divide by the new power. Ty, how about the antiderivative of 10x? 5x squared. And now I need to be careful with my notation here, because this, what I have now isn't quite right. I need those limits from 1 to 2. All right, we use the antiderivative. Now we want to use the limits. So 3 plus, plug in 2 to the 5th, plus 5 times 2 to the 4th, minus, plug in the lower limit, 1 to the 5th. That's safe stop. Let's see, 3 plus 32 plus, let's see, 2 to the 4th is 16. 16 times 5 is 80. So 3 plus 102 minus 4 would be 101. Uh-oh, did I do something wrong here? Oh, I did do something wrong. Nobody caught it. Anybody see where my mistake was? Didn't think that sounded right. 5x squared, 5x, somehow a 4th jumped in there. So 5 times 4 is 20. This is much easier to deal with. So 52.
41? No.
Minus, goodness, and then I really messed up this. 1 plus 5 is 6.
Yeah.
Yeah, wake up. 55 minus 6 is 49. There we go.
It's a lot more reasonable.
Calculus is easy, algebra is hard, right? That's
I think you mixed
demonstrated
up
that.
like the f prime 5x to the 4th with the later 5x squared.
All right, now I need a calculator. So
fine.
grab a calculator. You're welcome to go grab one of mine if you need it.
Could have grabbed one of the ones under your desk.
Yeah, there's one more under here.
2 more under here, actually.
Right there.
I would definitely not have caps. Why do you think I would have a cap?
Grab one of those.
Make sure it turns on
I
first.
think that's allergic to me.
All right. As always with a calculator problem, do not go straight to the calculator, right? Do the calculus first, then use the calculator. So if g prime equals that ugly thing, g of 5 equals 2, find g of 1. Okay, if I want to get from g prime to g, I need to integrate.
Yeah.
So the integral of g prime. But what limits do I want to use?
1 and 5.
1 and 5. I got to use my x values. So the integral from 1 to 5, that would be g of 5 minus g of 1. This time I'm trying to find g of 1, so I'm going to move g of 1 over and then subtract over that integral. Right, that's just a little algebra moving things around to get g of 1 by itself. Okay, g of 5 we know that's 2. Minus the integral from 1 to 5 of e to the negative sine x dx. Okay, now I'm ready to go to the calculator. So 2 minus, my calculator can do a definite integral. That's the fun part. So math, and then 9. Like math 8 was take a derivative, math 9 is function integrate, so integrate. And if you have a newer calculator, it'll do that. If you have an older calculator, you have to know how to put the thing in there. And
yeah, how do we put it in?
That's no good. If you get an older calculator, then you should probably trade it out for a newer calculator.
I want to figure it out.
I'll show you later. So because the formatting is so nice, all you got to do is put the right stuff in the right places. 1 to 5, e to the negative sine of x dx. And again, the calculator does all the work and spits out an answer, negative 2.970. This also means, by the way, on that worksheet from last night where you did all of those by hand, you could easily check all of those in the calculator because the calculator will do definite integrals for you. The calculator will not do indefinite integrals, so the calculator can't take an antiderivative. It can find area from a to b, but it doesn't know that the antiderivative of cosine is sine.
Again,
So,
the 3 decimal points.
3 decimal points.
Ew.
Number 3, let h be an antiderivative of that thing.
Yuck.
This is weirdly worded. H is an antiderivative of that.
So they're giving us h.
No, well this is an h, because h is an antiderivative of that. So that must mean that's h prime. That's exactly right. So h prime, worded quite strangely just to make us think, they gave us h prime. And then they're asking questions about h. So if you want to get from h prime to h, you need to integrate. So let's integrate h prime, and I don't want to write all that stuff, so I'm going to just go with h prime. From 3 to 7, because those are my x values involved in the problem. So that would be h of 7 minus h of 3. So trying to find h of 3. Yep, the algebra is the same as last time. H of 3 is h of 7 minus that integral. And I don't have to plug in, like when I'm showing my work, I've said what h prime is, so I don't need to rewrite that. I can just write h prime. That's sufficient.
Or you could label it as a, just to be nice.
Could. You'd have to make sure it would take extra work to do that, but you could label it something else. So I'm going to press pause. You see if you can put all that stuff in the calculator the right way to come up with the answer. So there's my answer. A mistake, or a common mistake on this, is is to basically forget to include the first known x value. You either just forget the pi, like you get so concentrated on typing that in correctly that you forget to include the pi minus. The fraction bar is alpha y equals, or alpha f1, and that makes it easy to put things in without having to mess with parentheses, or any more parentheses anyway. Number 4. If the integral from 2 to 9 of f prime, find something about f. Okay, well, if I integrate f prime, I get back to f. This one's worded a little bit differently as well, but that equals negative 1.6, but it also equals f of 9 minus f of 2. So this is a weird one. They just gave me the answer, but I had to recognize what they were giving me. So negative 1.6 equals f of 9 minus 3. So f of 9 is 1.4. That's kind of a weird one. Like that one had no calculations other than some adding and subtracting, but you had to recognize what they were giving you. Thank you, sir. Number 5 and final. There's my notes to self there. Friday, stop here. Stop herf. Stop here.
Stop her.
A graph of G prime consisting of 2 line segments and a semicircle is shown on the right. This is the graph of G prime. This is G prime. It's not the graph of G, it's the graph of G prime. If G of 3 equals 7, find G of 0. Well, again, they're giving me G prime and asking me questions about G. So if I want to get from G prime back to G,
You gotta take the integral.
I got to take the antiderivative, or the integral. So I'm going to antiderivative G prime, because that will tell me stuff about G.
From 0 to 3, right?
And we should probably use the x values that we're talking about. So from 0 to 3. Again, if it gives you f prime and asks about f, you're going to have to integrate. And then maybe you integrate with the calculator. Maybe you integrate by hand. What does the antiderivative from 0 to 3, what does that represent, or how do I find that from a graph?
You count.
I don't think I'm going to be able to count.
Well, you use geometry. That's what I mean.
Yes, we'll use geometry, because that symbol means antiderivative, but it also means area. So we have to always remember that it's antiderivative and area, kind of depending on the problem. Well, I should word that differently. It's always both. It's just a matter of which way to think of it helps. So the area from 0 to 3. Okay, so triangle is 1/2 base times height. So that's 3 over 2.
It would be 1/4 pi or something.
And that would be a fourth of a circle, so 1/4 pi times, let's see, r is 2.
Yeah. So just pi.
So just pi. And a lot of times people will label those, again, so if they have to use it for a different part of the problem. So the area from 0 to 3 is 3/2 plus pi, and that equals G of 3, which is 7, minus G of 0, which is what we're looking for. So algebra our way around here. G of 0 would be 7 minus 3/2 minus pi, which is the cleanest answer, but it's an acceptable answer. 7 minus 1/2 would be 5/2. 5/2 minus pi. and we'll stop there.
Okay.
Okay, so, and there's not really an assignment today. When we come back on Monday, we'll finish the rest of these examples, and then we'll assign worksheet 2. So, if you're really bored, you could start worksheet 2. If you're flying to Hawaii on Sunday morning, then just park this and hit it when we come back.